Good morning students, Vikas Global Institutions, Jangareddy. Last class I was discussed about the types of system and properties of the thermodynamics, and next one thermodynamic process. So thermodynamic properties: extensive property, intensive property, state functions and path functions, and later I was discussed about the thermodynamic process. What is that? Is the isothermal process. One is the thermodynamic process, thermodynamic process, and second one adiabatic process, and third one isobaric process, and fourth one isochoric process, and fifth one cyclic process. This is thermodynamic process last class. So adiabatic, isobaric, isochoric, cyclic process. So what is the thermodynamic process? The first one is the isothermal process. Isothermal process. Thermodynamic process lo first one isothermal, second one adiabatic, isobaric, isochoric, cyclic process. So in this isothermal process, the temperature is a constant. So delta T is equal to 0, and also we write the internal energy also 0, ERU. Internal energy ERU equal to 0. And adiabatic process. Adiabatic process, in the adiabatic process, what is the constant? In the isobaric process, pressure constant. Here the adiabatic process, Q is the constant, means heat flow is a constant, Q is equal to 0. Q is equal to 0. And third one, isobaric process, pressure is a constant, so delta P equal to 0. And isochoric process, volume is a constant, delta V is equal to 0. In the cyclic process, the initial state regained after some operation, so that is called cyclic process. That is called here internal energy delta E or delta U equal to 0, and enthalpy delta H is equal to 0. We write the delta E or delta U equal to 0. Okay. So in the isothermal process, the thermodynamic process of the temperature of system does not take place in the total procedure. That is called isothermal process. Simply we write the temperature is a constant, so delta T is equal to 0, internal energy also 0. And next one, adiabatic process. The heat flow is a constant, means the thermodynamic process, the heat flow of the change in the heat flow between the system and surroundings does not take place. That is called adiabatic process. So Q is equal to 0. And isobaric process, the pressure is a constant. The thermodynamic process, the process in which of the pressure, there is no change in the pressure of the total procedure, so delta P is equal to 0. So means does not take place the pressure. So in the isochoric process, volume is a constant, In the process of the system, there is no change in the volume, or a volume does not take place in the entire procedure, so that is called delta V is equal to 0. In the cyclic process, so in the cyclic process, A is converted to B, and B is converted to C, and C is converted to D, and D is converted to A. Here in the A is the initial state and final state also A. Here in the cyclic process, initial state and the final states are same. Here the initial state regain some operations, regain some steps, that is called cyclic process. So దీంతో పాటు ఇంకా 2 topics ఉన్నాయి అవి reversible, irreversible process. One is the reversible process, and second one irreversible process. Irreversible process. In the reversible process, so for example, we take the A, it is the reactants, it converts to products. Okay. And here B converted to A, B is converted to A, that is called reversible process. Reverse. It is a slow process. Reversible is the slow process. It involves the infinite steps. It involves the infinite steps. It involves the infinite times, infinite time. This is the reversible process. Reversible process means A is converted to B and B is converted to A. A to B, one step, and B to A, second step. So that means A అనేది B కింద కన్వర్ట్ అవుతుంది, మళ్ళీ ఏమవుతుంది B is converted to A. That is called reversible. It is a slow process. It involves the infinite steps and a total procedure in presence of the infinite time. That is the reversible process. And irreversible process, there is no reverse, means A is converted to B, enough. A is converted to B, enough. There is no steps involved in the process. That is called irreversible process. It is a fast process. It is a fast process or spontaneous process. Spontaneous process. Spontaneous process. It involves the finite steps. Finite steps. It involves the finite time. Fixed steps ఉంటాయి, fixed time ఉంటుంది. But in the reversible process, there is no time, there is no steps. Means infinite steps, infinite time. Does not fix the time and steps. But here the finite steps, finite time. Fixed the time, fixed the steps. That is called irreversible process. Clear na? Irreversible process. If the reversible is the slow process and irreversible is the fast process. Spontaneous process. It involves the infinite steps. It involves the finite steps. It involves the infinite time. It involves the finite time. It is A is converted to B, B is converted to A. Here A is converted to B. Enough, over. That is called irreversible process. This is the reversible process. Clear? And next one. And next one. Limitations of thermodynamics. The two limitations in the thermodynamics, limitations of thermodynamics. Limitations of thermodynamics. What are the limitations? In the total thermodynamics, majorly two major limitations are there, two main drawbacks are there in the thermodynamics. One is it does not explain the in case system in the equilibrium. It explains only system in the equilibrium. In case the system away from the equilibrium. Away from equilibrium. In the thermodynamics, explain only system in the equilibrium. What is the meaning of equilibrium? It is the stability. Means stability. For example, A is converted to B, B is converted to A. That is called equilibrium. Here A and B are equilibrium. A and B are stability, mutual understanding. A and B are mutual understanding. That is called equilibrium. Here in thermodynamics, explain only system in the equilibrium. In case the system away from the equilibrium and the system does not obey the equilibrium, does not explain. The thermodynamics fails to explain the system away from the equilibrium. It explains only system in the equilibrium, does not explain or fail to explain system away from the equilibrium. Okay, and next one, second limitation cannot explain or what does not explain idea about the rates of processes. Okay, so there is a second limitation. The thermodynamics cannot be idea about the rates of the process. It does not explain the rates of the process. But here the first limitation is the system away from the equilibrium does not explain means fails to explain and cannot be idea about the rates of the process. And rates గురించి explain చేయలేదు, అసలు ఇన్ఫర్మేషన్ అనేది ఇవ్వలేదు. దట్ ఈస్ ద థర్మోడైనమిక్స్ లిమిటేషన్. The two major limitations of the thermodynamics. One is a system away from the equilibrium does not explain the rates of the processes. Clear? And these are two limitations of thermodynamics. Okay. And next one, some objective bits చేద్దాం in the thermodynamics. ఇప్పటివరకైన టాపిక్స్ లో what are the topics చెప్పుకున్నాం మనం? Types of the system చెప్పుకున్నాం. Types of systems చెప్పుకున్నాం. నెక్స్ట్ వన్ ఏం చెప్పుకున్నాం చూడండి నేను ఒకసారి. టోటల్ క్లాసెస్ ఉందా లాస్ట్ క్లాస్లో సిస్టమ్ సరౌండింగ్స్ చెప్పుకున్నాం. టర్మ్స్ ఇన్ ద థర్మోడైనమిక్స్, సిస్టమ్స్ అండ్ సరౌండింగ్స్. నెక్స్ట్ వన్ ఏం చెప్పుకున్నాం టైప్స్ ఆఫ్ సిస్టమ్స్, టైప్స్ ఆఫ్ సిస్టమ్. అండ్ నెక్స్ట్ వన్ థర్మోడైనమిక్ ప్రాపర్టీస్, థర్మోడైనమిక్ ప్రాపర్టీస్. అండ్ నెక్స్ట్ వన్ థర్మోడైనమిక్ ప్రాసెస్. Okay, the total 3 days class. So system and surroundings, terms involved in the system and surroundings. Next one, types of system చెప్పుకున్నాం. Open system, closed system, isolated system, and homogeneous system, heterogeneous system. And properties లో state functions, state variables, path functions, extensive property, intensive property చెప్పుకున్నాం. And processes లో isothermal process, okay, adiabatic process, isobaric process, isochoric process, cyclic process, reversible process and irreversible process. And last one is the limitations. This is the total class of the last 2 days, limitations. So వీటన్నిటి మీద కొన్ని బిట్స్ చేద్దాం నేను. ఓకే, థర్మోడైనమిక్స్ లో వాల్యూమ్ 2 నేను. ఓకే, వాల్యూమ్ 2లో పేజ్ నెంబర్ 165, పేజ్ నెంబర్ 165 లో క్వశ్చన్ నెంబర్ 1. క్వశ్చన్ నెంబర్ 1, Dobbs thermodynamic laws speak about. Thermodynamics laws speak about. One is the option 1, rates of chemical changes. Rates of chemical changes. Number 2, option 2, feasibility. And energy transformation. Energy transformation of a process. Option 3, both rate and energy changes of a process. Option 4, energy changes in chemical reaction. Energy changes in chemical reactions only. These are the 4 options. Question is, thermodynamic laws speak about. We give the 4 options. One is the rate of the chemical changes, and second one feasibility and energy transformation of process, and third one both rate and energy changes of a process, and fourth one energy changes in a chemical reaction. So last class I have also discussed about the transformation of energies, and feasibility means done. Okay, so answer is the thermodynamic laws speak about the feasibility and energy transformation of process. That is second answer is the correct. Okay, and second bit is, the object under thermodynamic study. The object under thermodynamical study is called, thermodynamic study is called number 1 system, number 2 universe, number 3 surrounding, number 4 boundary. Number 4 boundary. చూడండి నేను ఒకసారి, the object under thermodynamical study is called, the object under thermodynamical study is called, చేయండి అన్న ఒకసారి గుర్తించుకున్నా, ఆల్రెడీ చెప్పున్నా నేను. సో సిస్టమ్, యూనివర్స్, సరౌండింగ్స్ అండ్ బౌండరీ, ద 4 ఆప్షన్స్ ఆర్ గివెన్. సిస్టమ్, యూనివర్స్, సరౌండింగ్స్, బౌండరీ. ద ఆబ్జెక్ట్ అండర్ ద థర్మోడైనమిక్స్, టోటల్ థర్మోడైనమిక్స్ గురించి చెప్పుకుంటున్నాం, సిస్టమ్ గురించి చెప్పుకుంటున్నాం. సో ఆన్సర్ ఈజ్ ద సిస్టమ్. Answer is the system. Okay, and third one is, which of the following are true about a system? True about a system. Number 1, option 1, will do not have definite amount, will do not have definite amount of substance. Option 2, energy and matter may not be exchanged with surroundings. Option 3, universe plus surrounding, universe plus surroundings. Option 4, universe minus surroundings. So answer cheppandi ana, which of the following are true about the system annadu ikkada chudandi. Which of the following are true about the system? We know the universe. So what is the universe? Universe is equal to system plus surroundings. We know the universe is equal to system plus surroundings. మన క్లాస్లో చెప్పుకున్నాం, universe is equal to system plus surroundings. The small part of the universe, system is a small part of the universe, and surroundings except system, remaining part is called surroundings. The total system plus surrounding is called universe, and the system and surroundings are under the category of the universe. So universe is equal to system plus surroundings. Which of the following are true about the system? System గురించి ఇందులో true ఏంటని అడుగుతున్నాడు. One is the will do not have definite amount of substance, energy and matter may not be exchanged అంటున్నాడు ఇక్కడ, may not be exchanged with the surroundings. And third one, universe plus surroundings is wrong. And fourth one, universe minus surroundings. So we write the system is equal to ఏమవుతుంది, సరౌండింగ్స్ ఇటు తీసుకురండి అన్న, సిస్టమ్ ఈజ్ ఈక్వల్ టు యూనివర్స్ మైనస్ సరౌండింగ్స్. సో ఆన్సర్ ఈజ్ ద ఫోర్త్ వన్, యూనివర్స్ మైనస్ సరౌండింగ్స్. క్లియర్? అండ్ నెక్స్ట్ వన్, fourth one, hot water in a thermoflask. Hot water in a thermoflask is an example for one is isolated system. Second one, open system. And third one, closed system. And fourth one, adiabatic system. Adiabatic system. So చూడండి ఒకసారి, హాట్ వాటర్ ఇన్ ఏ థర్మోఫ్లాస్క్. ఓకే, అంతేనా? కరెక్టేనా? హాట్ వాటర్ ఇన్ ఏ థర్మోఫ్లాస్క్ ఇన్ ఎగ్జాంపుల్ ఫర్ isolated system, open system, closed system, adiabatic system. What are the types of system? Based on the energy and matter, both are exchanging between the system and surroundings. The systems are classified into three types. One is the open system, closed system, isolated system. Here, what is the open system? Exchanging the energy and matter is called open system. And closed system, exchange of energy does not matter, is called closed system. Isolated system, there is neither energy nor matter. That is called isolated system. In the open system, we take the 1 cup of coffee. Take the 1 cup of coffee. And a closed system, we take the 1 cup of coffee. It is closed with 1 lid. Here the isolated system, we take the thermoflask. Here the exchange of energy and matter. Here the exchange the only energy does not matter. There is no exchange of the energy and matter. So we take the insulated thermoflask. We take the insulated thermoflask. So answer is the hot water in a thermoflask in example for isolated, open, closed, adiabatic system. Answer is the isolated system. Answer 1. Option 1 is the correct. Hot water in a thermoflask an example for isolated system. Okay, and next one, next fifth one, in open system, system and surroundings, system and surroundings exchange. Number 1, energy only. Number 2, matter only. Number 3, energy and matter, energy plus matter. And fourth one, neither energy nor matter. Okay, so in open system అంటే ఇప్పుడే చెప్పున్నానా, in open system system and surroundings exchange. So what is the open system? The system which can exchange both energy and matter. Exchange of the energy and matter is called open system. Closed system, exchange only energy. Isolated system, there is no exchange of energy. This is the isolated system. Neither energy nor matter, that is the isolated system. Here the energy and matter is the open system. Here the energy only, that is the closed system. So in open system, so what is the answer? Number 3 is the correct. Okay, next one, number 6. In a closed system, number 1, energy is not exchanged. Number 2, matter is exchanged. Energy is only exchanged. Energy is only exchanged. Number 4, energy and matter are exchanged. Energy plus matter are exchanged. Okay, so in a closed system, in closed system lo energy only exchange. So answer chudana, energy is not exchanged. Number 1, matter is exchanged, energy is only exchanged, and fourth one, energy and matter are exchanged. In the closed system, energy only exchanged. So here answer is the energy is only exchanged. Okay, next one. Next one, number 9. Number 9. Which of the following is a path function? And మిగతా బిట్స్ నాన్న మీరు ప్రాక్టీస్ చేయండి నాన్న. 7, 8, 9 చూడండి నాన్న. విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ ఎ పాత్ ఫంక్షన్? విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ ఏ path function? Which of the following is a path function? Number 1, internal energy. Number 2, enthalpy. Number 3, work. Number 4, entropy. Number 4, entropy. చూడండి నాన్న. So, which of the following is a path function? We know the state function, path function. So, what is the state function? It depends upon the system, and path function does not depend on the system. It depends only path. So what is the state function or state variable? State function ante enti, path function ante enti, or path variables ante enti. A state function depends upon the initial and final states, or depends upon the system. Here the path function depends upon the path, does not depends on the system. So here that is state function depends upon the initial and final states, and path function depends upon the path. So here the answer is which of the following is a path function? And one is the internal energy, enthalpy, work, entropy. In the state functions, what are the examples అని చెప్పుకున్నాం? టెంపరేచర్, ప్రెషర్, వాల్యూమ్. వీటితో పాటు మీకు చెప్పలేదు నాన్న, వీటితో పాటు ఎగ్జాంపుల్స్ ఇంటర్నల్ ఎనర్జీ E, ఓకే, ఎంథాల్పీ H, గిబ్స్ ఎనర్జీ G, ఎంట్రోపీ S. ఓకే, దీస్ ఆర్ ఆల్సో ఎగ్జాంపుల్స్ ఆఫ్ ద స్టేట్ ఫంక్షన్స్. టెంపరేచర్, ప్రెషర్, వాల్యూమ్తో పాటు ఇంటర్నల్ ఎనర్జీ E ఆర్ U ఎలా అయినా రాసుకోవచ్చు. E కానీ U అని కానీ కూడా రాయొచ్చు. సో ఎంథాల్పీ H, Gibbs energy S, entropy S. These are also examples of the state function. What are the examples of the path function? One is the work, and second one is the heat. These are examples of the path function. So question is, which of the following is a path function? Internal energy is the state function, enthalpy state function, entropy state function, work is the path function. So answer is the third one. Which of the following is a path function? That is a work. Okay, next one చూడండి నాన్న. నెంబర్ 10, 11 చూడండి నాన్న. 10 మీరు చేసుకోండి నాన్న. A process in which no heat change takes place is called okay. Number one isothermal process. Number 1 isothermal process. Number 2 adiabatic process. Number 3 isobaric process. Number 4 isochoric process. So a process in which no heat change, ఇది కూడా నన్ను ఈ పాయింట్ చూడండి ఒకసారి. A process in which no heat change, that is the main answer. A process in which no heat change takes place is called isothermal. The temperature is a constant. Adiabatic, heat flow is a constant. Isobaric, pressure is a constant. Isochoric, volume is a constant. So a process in which no heat change takes place is called, answer is ఏమవుతుందన్న adiabatic process. Adiabatic process. Here thermal is the temperature is there is no change of the temperature, isobaric pressure and isochoric volume, and the remaining one is the answer, that is the adiabatic process. In a process in which no heat change takes place is called adiabatic process. Okay, and next one. For a cyclic process, నేను 12 చూడన్నాను, a gaseous system 12 12 a gaseous system changes from state A, P1 V1 T1, B P2 V2 T2, C P3 V3 T3, C P3 V3 T3, and finally from C2A, the whole process is called okay, option 1 cyclic process, option 2 reversible process, option 3 isobaric process, option 4 spontaneous process. So చూడండి అన్న ఏమంటున్నాడు క్వశ్చన్ చూడండి, ఏ gaseous system changes from state A, P1 V1 T1, B P2 V2 T2, C P3 V3 T3, and finally from C to A whole process is called. క్వశ్చన్ చూడండి అన్న ఒకసారి, A is A to B అంటున్నాడు, B to C అంటున్నాడు, B to C అంటున్నాడు, B to C అంటున్నాడు, and C to A అంటున్నాడు. So a gaseous system changes from state A, B, C, and finally from C to A to B, B to C, and C to A whole process. It is total process. This total process is called. That is the answer. Most question cyclic. The cyclic one is the reversible and isobaric and spontaneous. In the spontaneous process, that is called irreversible process. And isobaric pressure is the constant, and reversible it is the slow process, and last one cyclic process. So A is the initial state and finally we get the initial state A, so it is the answer is the one cyclic process. Okay, and next one 13. For a cyclic process, the condition is option 1 delta U is equal to 0, option 2 delta H is equal to 0, option 3 delta U is greater than 0 and delta H greater than 0, and option 4 both delta U 0 and delta H 0. Answer చెప్పండి అన్న. The cyclic process లో మీకు చెప్పున్నాను, in the cyclic process లో here the internal energy and enthalpy both are 0. So for a cyclic process the condition is delta E is equal to 0. Okay, it is isothermal process. Delta H is equal to 0? No. Delta E is greater than, delta H is greater than 0? No. And fourth one, delta U is equal to 0 and delta H is equal to 0. Already we know in the cyclic process internal energy and enthalpy are constant, so delta U and delta H are 0. Clear? And last one, 14th. An adiabatic expansion of an ideal gas always are. Always are. Number 1, constant temperature. Number 2, Q is equal to 0. Number 3, W is equal to 0. Number 4, delta H is equal to 0. So answer cheppandi nana. An adiabatic expansion of an ideal gas always or. Adiabatic means heat flow is the constant. There is no change of the heat flow with systems and surroundings. Heat flow does not take place in the process, that is called adiabatic process. So constant temperature is isothermal process. Q is equal to 0, S, that is adiabatic process. And W is equal to 0? No. And delta S is equal to 0? No. And finally answer is the Q is equal to 0. An adiabatic expansion of an ideal gas always or Q is equal to 0. Okay. This is the today class. So today class is reversible irreversible process. Today class is reversible irreversible process. And next one em cheptunnam nana limitations of thermodynamics, and next one some objective bits on the systems, types of systems, properties of the thermodynamics, process of thermodynamics, limitations of thermodynamics. Okay, thank you nana. Tomorrow I will continue. Thank you students.